The first published document in the area was a field guide from the 1965 Caribbean Geological Conference. This identified the main structural and stratigraphic features that can still be seen today. On this topographic map, we see the location of the outcrops in relation to the beach facility. The Kugler surface geology map shows that this area is considered to be Upper Cruse. The Lengua outcrop, however, cannot exist within the Upper Cruse as mapped. Payne et al. In 2007, based on paleoanalysis of 5 exploration wells drilled by Quinam, discovered that the surface outcrops were actually forest or younger. All the geological maps identified a number of faults which were then used to model this new interpretation of the geology. On this terranet plot, there appears to be 2 distinct groups of strike orientations. This agrees with the map trends of sand beds on the Kugler surface geology map. The abrupt change near Roja Point may be due to faulting. However, no outcrop evidence is present to support that conclusion.
Good morning, we are at Quinam Beach. Tide is currently falling. We are looking out into the Columbus Channel and we are looking east towards Palmies Point. We see that the wave cut platform is completely covered by sand already, even though the rainy season is just 1 month old. At our first outcrop, you see we have a slumped claystone section that has large boulders of sandstone floating in it.
At this claystone-dominated outcrop with large floating sandstone clasts, plots on the Kugler map as being Lengua Formation.
At this outcrop here, we are seeing near vertical claystones on the right, and on the left we are seeing a series of slumped sands. The base of the cliff is fringed by an apron of large boulders. At this point here, we see the remnants of a boulder berm that was constructed in order to protect the shoreline. Here we see that it's partially buried by a slump, but further along the beach we see that it has been completely removed by wave erosion. In the distance we are seeing Roja Point. So again, we are now looking at sand beds, and basically we are seeing a big section of sandy clays. In this case here, we see what appear to be near horizontal beds that are probably representative of a slump. Beds on this side here are near vertical and consist of alternating sands and claystones. Which are all heavily faulted. Here we can see a normal fault. So, heavily faulted siltstone outcrop. and you can see these beds dip seaward. So we are really now on the south side of the southern anticline. And if we look at this bed, the base of this bed, you see a number of micro faults. What is noticeable, there is no bioturbation of these particular sediments here. Here we can see a large concretion floating within these slumped sands. Oh, this here is a very large block of sand floating within near vertical faulted alternated sands and clays. These clay stones are also very heavily bioturbated. So we can actually see the edge of one of these slumps right here. They have a series of parallel, well, ripple laminated clay stones with the actual surface of the ripples being exposed in this series of alternating sands and clays. Also notice further up on this cliff there seem to be a series of near vertical fractures. We're also seeing fairly thick sandy bed underlain by a light grey clay stone, which we are able to get a close-up view right here. These clay stones are also rippled on their top surfaces. So again, we're seeing fairly steeply dipping, alternating sand and clay beds dipping towards the south. So you see some rip-up class at the base of some of the beds in this particular section. We are seeing thin carbonaceous layers between the sands, within these clay stones. We see a number of fairly large clasts within this bed here, which probably represents some kind of erosional lag at the base of a channel. Once again, we see ripples in this section. So here we see a close-up of the clast bed that is unweathered. Here we see a fairly large slump fold within a clay stone. Here we are seeing a folded sand bed within a slumped section here. This here is the mouth of the Indo-Nudo River according to our maps. Slumping of clays is very common in this coast, and as a result there's fairly significant coastal retreat all along these claystone dominated sections on the south coast. We are now approaching a partially weathered, parallel laminated, parallel bedded, alternating sand and claystone outcrop. That does not appear to be impacted by either slumping or faulting. Let's take a close-up view of what these claystones look like. Here we see, based on the colors, there's some kind of cyclicity in the deposition of these claystone units. Here we see a close-up of the top of one of these sandy units.
Here we see slumped claystone beds overlain by parallel bedded alternating sandstones and claystones. The uppermost bed show cut and fill geometries, and dips are 63 degrees with a strike orientation of 122 degrees. This claystone bed has a combination of rounded clasts floating in the claystone or areas where it appears to be a clast supported conglomerate. Here we see two normal faults within the claystones of the wave cut platform. If you have enjoyed the video to this point, stay tuned for part 2